So I can go ahead now and save this marked chirp as my reference waveform by going down through the menus and pulling up the option to export that marker delimited data to a output file. And I've already done that and have actually called it a good LFM. So I'm going to go ahead now and do the waveform search, again looking for, or using it hopefully, to look for situations where I not only find good matches to this chirp, but more particularly in this particular case, in this particular problem, find bad matches to this chirp. So instead of setting the confidence level to 90% or 95%, something to represent nearly an exact match, I want to look at and include in the results list those situations where the waveform search came up with a low correlation, and show those to me as well. The input file is going to be the file that I had previously saved as good LFM, representing the marker delimited export of this chirp time sequence. And I want to go ahead and search through the entire file, because at this point I don't know, and in fact that's the problem, I don't know where in the file the bad chirps are located. So if I go ahead and apply that criteria and start the search, what's going on is that the program is taking this time slice, correlating it across the entire file, and every time it finds a match, and in this case it found 6,400 matches, it's going to tell me where the chirp was in the frequency domain relative in offset to the match, or to the reference that I used. In this case they all seem to be centered at 0, so there's no shift. Where it occurred in the file, and the correlation confidence. So if I look and just pick one, for example, at 99.99% confidence level, you can see in fact that it was nearly an exact match, very linear, spread across the same frequency domain, and lasting for the same amount of time as what's shown in the slightly more zoomed in display of the spectrogram. But if I scroll through this list, I can start to look for correlations that were lower than this 90% threshold or 95% threshold where most of these are coming up. And sure enough, at around 78 milliseconds, I find one that was a confidence level of 24%, 24.07%. And sure enough, instead of it being a linear chirp, it's a down-up chirp. Still a chirp, still FM sweeping, so there was some correlation, but clearly and visually now the reason for that chirp being of a lower confidence level. So what we've done here is very quickly been able to isolate where in the file the bad return occurred. Since we know the exact time of day when the file recording began, we then know the time of day when this bad return occurred, and that would provide a very valuable clue to the designer to correlate that against what may have been going on the aircraft itself that was being painted by this radar system. Perhaps something physically showed up on the radar range that may have caused a multipath or perturbed the return channel, and could have given reason for this bad chirp to occur. So a very, very powerful tool. One other thing that can be done is these results can be saved to a file. They could be brought into a simple program such as Excel. The results sorted in columnar data could be sorted, and very quickly you could sort it in ascending order, therefore allowing this low confidence level result to show up at the top, and then very quickly scroll back down through this list, find the matching time, and that would be the quick and easy way to locate where that bad chirp and bad return is in your file.